Technology can be the knowledge of techniques, processes, and the like, or it can be embedded in a machine to allow operation without detailed knowledge of their workings. Good evening, everyone. I'm Timeth Pereira, and I will be the moderator for today's Techno Meetup session. I welcome all of you to the third session of IEEE Techno Meetup webinar series. If any questions arise during the webinar, you can either use the Slido link we have provided or the Zoom chat box to submit them. Over the past years, Techno Meetup Sri Lanka has brought to you knowledge about different topics, trends which are related to cutting-edge technologies in the industry. Today, under the monthly theme of machine learning, we bring to you human languages from machines' point of view. The speaker of the day is the chief data scientist at Sach Consultancy and a Google developer expert in machine learning. He is the founder of GDG Sri Lanka. He started his career as a software engineer, then moved on to Google Inc. as a country engineer consultant, and then to Google AI as a researcher. I warmly welcome Mr. Keshan Sodimana to show us the way how machines understand how human languages from their point of view. Over to you, sir.
Right. So I know this webinar format is a bit intimidating at first, but I think everybody is now getting used to it, right? Because you can't see the audience or you can't get the feeling of the audience. So, but I think we are all getting to it now. So anyway, today's topic that I selected to talk about is human languages from machines' point of view. Because human languages, we all know that we use languages to communicate with people, and it's cool that if we can communicate in the same languages with the machines. So as maybe most of you guys have a programming background, you know how to communicate with a computer in a programming language. But how cool is it if we can communicate with the machine in a human language? So today we are going to maybe to understand some of these components and to know what are the components in this kind of technology. So if you have, I think most of you have a modern smartphone. So you have definitely used either one of these: Google Assistant, Apple Siri, or Microsoft Cortana, or Amazon Alexa, and there are so many other assistants that are available today. So if you have used one of these things, you know the experience, the feeling of speaking to your phone or your machine, your device in your, maybe not your native language, but in a language, in a human language, right? So I don't need to explain you or introduce you how the feeling or how to do that in a practical sense. So without going into that format, let's dive into the technology part of it. So before talking about machines, let's understand what is a human language. So languages are there to communicate a certain idea or concept between different human beings. So the human languages, I think, started with small sounds, maybe some gestures, some signals, but with the evolution of hundred thousands of years, now we have languages which are very sophisticated, which we can use to communicate very abstract ideas and concepts. But not just one language. We have thousands of language in different parts of the world, and even the same language that people speak in different ways, right? So if you take English for an example, in Britain they speak in their way, and there's a slight difference in the way of people in the United States speak the same language, right? Sometimes that's the accent difference, sometimes the vocabularies are different, I mean slightly different. So there are so many differences even in the human language, in one human language. So the challenges are there. How we can teach all these challenges and all these nuances to a computer. Okay, so if we take the same context as a human being, so we have the ear to listen, and then we have the brain to process whatever we listen, and then we have the mouth to put them in again into speech, right? So that's how we use language. And when it comes to the mashing, we can simply map these entities to, for example, ear as the speech recognition part, where you, as you listen with your ear, speech recognition is the part where it has a mic to get the audio and convert it to a human language, probably. And the natural language part is natural language understanding and generation. So natural language understanding means whatever you say, it has to be understood. Like what is the intent of that particular statement, what the person is asking, or what he or she is trying to convey. So understanding that part is under natural language understanding. And then you have a natural language generation part. That means after you understood it, maybe you have to give a response. Like for example, if you ask Google Assistant or Apple Siri about who is the president of United States, then it has to first understand what the question is, what is the intent, and then what that person is asking. Okay, he is asking about the president of the United States. So then it has to go and fetch whatever the response to it, and then after that it has to generate a response, like the president of the United States is Donald Trump. So that statement has to be generated, and after that you have the mouth part, that is the text to speech. So now we have a text, and then it has to be converted to convert back to a speech, right? So that is text to speech. Speech recognition is also called as ASR, that is automatic speech to text sometimes. Speech recognition, ASR means automatic speech recognition, but sometimes people are calling it as speech to text. So don't mix up those two things. So speech recognition is speech to text, and text to speech is whatever the text that you will be spoken out, right? So if you have any questions, maybe you can even ask between the session, because that's how I'm used to when I'm doing a session. So feel free to ask any questions, interrupt me and ask a question. It's fine. So is it clear up to now? Okay. If you're silent, that means it's clear, right? Okay. So let's talk a bit about speech recognition. So how we recognize speech. So what's, okay, before that, what is a speech? So when we want to convey something or communicate something, what we do is we will simply speak. Like your mouth will displace the air molecules in front of your mouth with some kind of energy in a certain pattern, right? So that's what speech is. And your ears can detect it. Your ears will get that waveform, and since you have already been exposed to those kind of examples from your childhood, you can identify a pattern, and based on that you can come up with a language kind of a representation. So that way our ears can identify these different waveforms and come up with a language representation in our brain. Why? Because from the childhood we have been trained, or we have listened to, and we have seen so many similar similar patterns, right? So whenever we hear a similar sort of waveform, or let's say a sound, we can identify it as that particular word or a sound. Imagine if you don't know a language, like let's say if you don't speak language in Africa, and if you hear that language for the first time, it's, I mean, you can't understand what they are trying to say, because you don't have this training data in your head. Like let's imagine your brain as a neural network. Your brain has not been trained to understand that language, right? So the speech recognition is not a new thing. It has been there for like 50, 60 years, I guess. Like in the 1950s, even in the 1950s, they have been doing some research to come up with speech recognition technologies. But back then they were trying to come up with different rule-based scenarios. Sometimes, so because one thing is that they thought that whatever we hear, they can model it in a mathematical way and put it into the computer and let it understand and that in that way. But those were those were not very successful, because there are a lot of differences in the way different people speak, and maybe the environmental sounds are there, and sometimes even the same person when speak a different language, there are a lot of variations. So it didn't it was not successful. So but in the recent years, if I call it as the deep learning renaissance period, let's call it in that way. Uh, uh, the main difference happened in deep learning era. Let's call it the deep learning era, which is like post 2012 kind of time period. Uh, that what happened in that time period was people were trying to use like there were few different few things that changed the overall picture of deep learning. One thing is there are a lot of data. There are tons of data that we create every day, and researchers have access to those data. And the other special thing is the hardware improvements. So people started to use GPUs. So GPUs are, if you are a gamer, you know what a GPU is. It's a special component in your machine which can do lots of computations, like mathematical operations, like matrix multiplications, which is very important to deep learning, in like machine learning in general. So people like some researchers started using these GPUs along with a lot of data with improved algorithms and other improved techniques to train neural networks, and uh, that produced a lot of amazing results. So one of them is this speech recognition, where they didn't try to give like tell the machine the rules of a particular language, because if you think about yourself, I'm pretty sure most of you guys speak at least two languages. If you think about your second language, when you were studying, maybe most probably that is English. You studied for like 13 years, but it was a struggle, right? For most of you guys, it's a struggle, like including me, like learning English, which is my second language, was a pretty struggle. But if you think about, and that's in the school, but how we were taught was we were taught in like we were taught different rules, different maybe grammar rules, like different stuff in the language, and by by understanding those rules, we try to speak the language. But if you think about your native language, it could be Sinhala or Tamil or whatever your native language is, you picked up without without much effort, right? Like at the age of 2 or 3, you started speaking that language very fluently. Uh, so how that's possible when you are when you are around 2 and 3 years old, you could pick up a new language, which is your native language. Uh, but when you're going to school, you studied another language for 13 years, but still it was a struggle, right? So the difference is in your native language, you are not taught the rules or grammars of that language. What your parents or your whatever the elders did was they spoke to you. They talked to you in the language. Uh, so in that way, you started listening and and try to understand what are the things that they are trying to communicate, and you try to imitate it, right? So that's how you learn you learn your native language. So the same thing happens with deep learning in speech recognition. What we do is we don't give rules to the machine. Instead of that, we give a lot of data, like a lot of utterances, that means recordings of different sentences along with the sentence in text, and it will try to understand a pattern between these sounds and the text itself. So the simplest way of explaining it, but the algorithms have a lot of different complexities in order to understand. But in the simplest terms, that's how it does. We just give bunch of data, like a lot of data, tons of audio samples, and along with the text of that audio sample, and let the machine to learn by himself or itself or herself, whatever you call it, politically correctness. Right? So, and this is a data set that Google. So during before before this time, like before 2018, I worked at Google as a country engineering consultant, and also at Google Research where we did speech related researches. In like my team was part of a low resource language speech like system development team. So this data set is from Google Research where we used to train the Google automatic speech recognition. So the Sinhala, if you like, I think most of you guys speak Sinhala. So this data set is the same data set that we use to train the Google's speech recognition system. So which is open source, and feel free to use it for your research purpose. Yeah. So the next part, now we know the ear part, and then the other important part, which is the natural language processing, according to our analogy, which is the brain, right? So this natural language processing has become a very hot, trending research area in the last couple of years, I guess, because people started first when in deep learning. First, people started working on the computer vision types of problems. They started like first they started with classifying image data set back in 2012, 13, 14, that time period. Once they have achieved a very good results on that, they then went on to different other areas. So one area that people have come to in last, most probably in the last 2-3 years, is natural language processing, and there are a lot of improvements, advancement in this area. Like for example, something called transformers. So these transformers changed natural language processing dramatically in last, I think within last 3 years, because it prior like before transformers has become a mainstream thing, people are using LSTM, something called LSTM and recurrent RNN for sequence-based problems. That is speech, maybe language, maybe even time series kind of problems. People are using LSTMs, right? But then in 2017, if I'm not wrong, somebody has come up with this new idea called transformers. And then I think it was first used by Google, if I'm not mistaken. The model was called BERT. That was a different, it made a lot of difference, because BERT didn't need text label data, right? So in a machine learning project, usually what you want to do, what you want to give the machine is data set. Mostly, like if it's a supervised task, there are tasks, in machine learning, there are something called supervised problems and unsupervised problems. So speech, let's say for example, speech, we can give the audio as the data set, and the transcript or the written text as the label to the neural network. So sometimes the not sometimes, like most of the time, the problem was not getting the data set, but like transcribing it or labeling it. Even for image related problem, you just need images plus the label, right? So if it's a supervised based problem. So what transformers did was for languages. So before that, like I was saying, people are using LSTMs and all these other different architectures to for these kind of problems. They have to use a lot of data, label data. So somebody has to sit down and write, like let's say if you want to write kind of a grammar-based language model. then somebody has to sit down and write each of the words, like this is a verb, this is a noun, this is adjective, etc. And then after we have tons of this data, we can train a model to identify what's a noun, what's a verb, so and so. But with transformers, it changed. Like you don't need to give the label data set data anymore. uh, you can throw a lot of data into this model, and it will try to understand different kind of patterns or uh, different things in language, in a particular language. So as a result, we now have a lot of advanced models. Like for example, this one was very recent, called GPT-3. Uh, so this is one of the examples. So somebody is like using natural language to come up with a design. So that's pretty cool, right? So now don't worry if you are a designer or a programmer. Don't worry that now your job is not going to lose because of that. These are very primitive, and I think this is one of the tools that you can use to complement. Like if you are a designer, you can use this tool to be more productive. So it will not replace your job, but it will be a complementary thing for your day-to-day work, maybe in the future, not now. So this is one of the examples, and there are tons of examples. If you search GPT-3 on YouTube, you can find out a lot of cool stuff that they have been doing. And this model has like I think more the like 175 billion parameters trained, and training that kind of a model is not for you and me kind of people. It needs like millions of dollars to train such a model, so we can't afford it. So big players like Google, Facebook, Amazon can afford it. And this GPT-3 was done by a company called OpenAI, which is backed by Elon Musk. So of course, they are doing a lot of crazy stuff, right? Uh, so so that is about natural language thing. So the take home is from natural language part is that it's the brain or the whatever processed by the ears or the speech recognition has to be understood and then generate a response. For example, if it's a assistant or Apple Siri kind of a solution. So in the recent years, the natural language processing community or the research area has become very hot. It's a trending area. So if you are maybe willing to go into a research area, probably that's a good area right now, because so many people are doing research on these areas. Especially they are doing research on many languages, including English, maybe Hindi, Japanese, those kind of languages. But uh, most probably languages like Sinhala, even Tamil has no not much of research being going, because it's not their interest to do research on these languages, because they don't have any emotional or even business related requirement with these languages. So if you are interested, probably that's a low hanging fruit in this domain, because nobody will be doing research related to our languages, right? It's us who should go and do these researches. So now the next thing is the mouth part. So now we know the ear part, the brain part, and then the mouth part, which is called the text-to-speech. So I can explain this a bit deeper, because we were like when I was at Google, our team was responsible for developing speech recognition systems for low resource languages. So low resource languages means languages like Sinhala, Tamil, and so many languages in India, like not Hindi, but languages which are spoken by hundreds of millions of people. Like for example, if you take languages like Bengali, Punjabi, uh, it's spoken by hundreds of millions of people. But when it comes to resources like language resources, which researchers has to use to develop this kind of tech like systems, they are very rare, because not many people are doing this research. So our task was to come up with something good without using tons of money and tons of resources. So I'll be explaining you some of the things that we did. so you may get a better understanding, right? So yeah, how we built signal text to speech. So when we started doing it, so one thing was that even at Google, Sinhala was not a priority language. You know, it's spoken by only 16 million people, and not many people who speak the language are inside Google. So it was not a priority, and they were trying to do stuff in India and Indonesia and all these other big countries, big markets. But we were lucky because we had a good community here, like especially developer community was very strong here. So because of that, I could convince them to do something for similar language. I mean, we then because since our target was to come up with systems which uses low resources, like not many resources, not much resources, and in a low cost manner, like so our method was to come up with a way for anybody to build these text-to-speech systems without burning millions of dollars. Like for example, if you take languages like English, right now Google has invested millions of dollars to make a text-to-speech system for languages like English, maybe Japanese, Chinese, those kind of big languages, but they don't have any I mean, they don't want to invest that kind of money to language like Sinhala because they don't see a business value, or maybe it's not very high priority language probably. So because of that, we had to come up with something new. So what we did was we started collecting data in a crowdsourced fashion. So we can collect data from the people in the country who speak the language, who understand the language, who understand the culture. So we created a small app. This is not about Google crowdsource app, right? This is a different thing. We did this data collection, I think, 6 years ago. And what we did was and there were certain qualities that we had to maintain. Because this is a text to speech. This is not speech recognition. This is text to speech. So in speech recognition, when you do the data collection, you have to collect data from different backgrounds. Like you have to collect data from the road, like with buses passing by, and maybe in in a quiet room, and also in different areas. But because speech recognition means you can speak to the phone in any kind of environment. But text to speech is different. Text to speech is it's not it's we have to come up with one certain voice for a computer. So it's the personality of the computer, right, or the phone. So whatever we picked as the baseline or the reference voice should be culturally and linguistically correct. Like let's say, so we in modern day speech text to speech systems, you always see a female voice, right, which is, I don't know, somewhat uh, good to hear. Like some like the pitching is very high, it's smooth, like it's nice to hear when a female voice being used by Google Assistant or Apple Siri. And the personality of the voice has to have different kind of like guidelines, right? Has to follow a different kind of guidelines, because if the voice is rude, then you will not use that system. So it has to follow, and culturally, like sometimes, like it has to be culturally compatible. So there are things like non-technical stuff that you have to even understand when you are choosing a reference voice. So, but for us, the problem was we can't use a professional artist or professional, like somebody professional who can uh, give the voice to us. Like, for English, like, there are famous actors have been used to give these voices, but here we can't do it because our main goal is to come up with a method so anybody can reproduce this same methodology without using like without spending tons of money. So what we did was we try to identify like females who are in 20 to 30 years category, and we collect data from multiple people. Like I think for singular we had 12 or 14 speakers, and we asked them to record 200 sentences by each. So we had around 2000 to 2500 utterances. Uh, and then, so these utterances we have, so when we are recording these utterances, the recordings has to be in a certain condition, like it should be in a quiet room. It's better to have a studio setup. Like if you take, for example, a language like English, they have uh, a professional studio. They have professional like voice talents and some like sound engineers. But in our case, we didn't have that. So what we did was we created our own setup, which is very very inexpensive. We use a laptop with a fanless laptop because the fan can give a noise which could interfere with whatever the recordings. And we found a quiet room to do the recordings. So once we did the recordings, we did some quality assurances, because sometimes even though we had this setup, there could be some mistakes, maybe some mismatch between the utterance and the text, or maybe some other background noises. So we did the quality assurance, and after that, after we did all this quality assurance work, we used that data set to train our models. uh, and and that's one part of it. So there are other components in a TTS. Like for example, there's another component called G2B, like graphing to phoneme. So in a language, you have I think I have time to explain this stuff, right? Okay. So so if you take a text to speech system, you need to have a way to convert these different graphemes. Let's say the letter R, right, or letter A. You need to convert it into it, into a representation where the machine can understand. Or there should be a non-ambiguous representation. For example, if you take English words like put, put, and cut, cut, the U has different sounds, right? When you write cut, it's the U sounds like cut. But when you write it as put, it's put, like the U sounds like oo. So there's a ambiguity there. So in order to understand this ambiguity, remove this ambiguity, we have to make it to a kind of representation where it's a standard without any ambiguity. So which is called IPA, that is International Phoneme Standard something, alphabet, International Phoneme Alphabet. So so once we do that, we have to train a model to convert these graphemes into phonemes. So phonemes are the atomic level of the sounds, right? So in Sinhala we had one issue, like the schwa is like you can say mama, right? If you write my mama, the first ma is like ma, like ma, but second ma is ma, right? Mama, not mama or mama, right? So when you write it like ma, that like when you're chatting in Facebook, right, or wherever you type ma, right, for mama, but that's very ambiguous because you can't say mama or mama or something like that. So in IPA we it removes that ambiguity. So there's a special character called schwa, which will be used as the mer sound or m with that schwa sound. So so then you have to train a model to give that, like given a letter or a sentence or a word, it has to give that non-ambiguous representation of the language, right? And then we use that to train the model with the given audio forms. Uh, but before that, there's another thing. There's something called text normalization. So this is a text-to-speech system, but in a normal text, you don't have just text. You have numbers, you have dates, you have time. Like even in a number, like if you put $sign before 1.25, it's $1.25. But if you remove the $sign, it's 1.25. So what text normalization handle is, given a sentence, it will make everything into a sentence, like a written sentence in letters, by removing all these $signs, all these currency symbols, times and dates, and it will generate a sentence in that given language, and then the G2P will convert it to the representation, as I said, the IPA standard conversion, and then use that representation to train the model, right? So that's how, in a nutshell, how it does. And already the singular TTS data is also available for anybody to download and to research or play around with. Not just the data, but there are tools, like we have built open source a data tool called Voice Builder, which is a tool to make use of these data sets and build text-to-speech systems without doing modification or the technical work. Sorry. Uh, and yeah, and also the text normalization stuff that I mentioned earlier, all the things are open source. And again, I have to say that languages like Sinhala or Tamil or whatever that we speak, I think we have to do the research by ourselves, because the technology is there. If you search the literature, like the speech, text-to-speech literature, there are so many methods that people are using to develop this English and other big languages. So maybe you can try out, but of course there are some stuff that you need to have like a lot of computing power. But again, there are some things that you can even try out without using a lot of computation power, and even with the available free resources like Google Colab and other instances that you can use for free. So I encourage you to use these resources and do something. And yeah, and that's it, I guess. So right on time. That's it. Any questions?
Thank you very much, sir. That was indeed a very interesting session. I think all of you got a good idea about machine learning and also about singular text-to-speech. We apologize for the inconveniences caused due to power cuts, connection problems, and other technical issues. I thank you all for understanding the situation. With that, let's move on to the Q&A session. You have asked some interesting questions via Slido and Zoom chat. We'll be answering some of them. Let's move on to the first question. Uh, Existing text-to-speech libraries have problems in converting low-quality audio to text. What should we consider if we are developing such libraries? I think
Yeah.
Mr. Keshan,
Yeah.
you need the answer.
Let me first. So the question is converting low quality audio, right, to text to speech. Is
Yes.
that correct? Yeah, that's why I said when we were collecting the data for text to speech systems, we were following a certain guideline because the quality is a really it matters a lot. We need to have high quality recordings to do a text to speech system. So the question is correct. When the data is low quality, it's hard to build text to speech systems. So I don't right now I can't say how to use these low quality data to make text-to-speech systems. But what I can say is you can use the open source Google dataset, the text-to-speech dataset, to do your research, because I believe that the open source dataset, the Google open source dataset, has the quality is higher than whatever available right now. Yeah, I think, did that answer your question?
Yeah, I think that answered the question. Thank you, sir. Let's move on to the next question. What sort of data is required to process natural languages?
Uh, Depends on the problem. So okay. So building these models like GPT-3 or BERT, so they have done it for languages like English and all these big languages. I think there are a few models even with Sinhala, like for example, Roberta, if I'm not mistaken. It has Sinhala, but problem is they have been trained on the Wikipedia articles. So if you take a number of Wikipedia articles that we have for Sinhala is very limited, so the quality is could be very low. So they were asking like what kind of data that they need to train such a model. So let's forget about the single language. Let's say in general, like for example, language like English. If you want to come up with let's say a sentiment analysis kind of problem, you can use the pre-trained model like the BERT or other model that has already been trained with tons of data. You can use it and then with a limited number of data samples, you can retrain it. Like you can do the transfer learning. So if you are familiar with transfer learning and all this deep learning stuff, you know how you were doing transfer learning for the images, right? Using the pre-trained image models, you could retrain another model to do your predictions without using a lot of data. Similar thing can be done for languages by using a pre-trained model like BERT or other models available. So you can go to Hugging Face and find out what are the pre-trained model that's available right now, and use those models. And with a small data set, you can like do the transfer learning or retrain the model to solve kind of a problem. Like it can be a question answering problem, it can be sentiment analysis. So depending on your problem, the data that you have to produce for the give to the model may be different. But for languages like low resource languages like Sinhala or Tamil, it's pretty hard because training a bird like model is pretty computationally expensive. I'm not saying we can't do it, but it needs a lot of resources. Yeah, so feel free to try if you can.
Yeah. Yes, I think that question met with a satisfactory answer. Thank you again, sir. And there's another question. Someone has asked that sir mentioned in this webinar that there are some issues when creating a data set. How do we cover those drawbacks?
Creating data set issues. I didn't get
Yeah.
the question correctly.
Uh, he says that there are some issues when creating a data set. How do we cover those drawbacks?
Okay,
I think the
so
question means how to
it's
avoid
big.
problems.
Yeah, so
Yeah.
it's a general, it's a big question. Like if I were to ask answer like so for example like speech related data set. If I talk about speech related data sets, when it comes to text to speech, yes, there should be a certain guideline to do the data collection, because otherwise uh, the the results may not be good. Because in machine learning there's a thing called if you put garbage into your model, whether it's the best model in the world, it will give you garbage out. So the data set is very important. So most of the time in a machine learning project, you spend a lot of time like cleaning the data, collecting the data, cleaning the data, understanding the data, and doing, like, we call it massaging, like massaging the data. Uh, so it's very important. It's one of the most important part of machine learning pipeline. So yeah, the data collection has a lot of lot of challenges, like depending on what kind of data that you're trying to collect. So it has to be answered case by case, like what is the problem and where the data is coming from, and what kind of data that you need. So based on that, the, the the techniques that you use uh, to remove these problems will change.
you, sir. And let's move on to the next question. Uh, the questionnaire is asking, can you give some inputs on how to recognize violence in a speech by considering the context? Because the words can have different meanings depending on the context.
Yeah. So for that, I think there was a very popular Kaggle competition called Toxicity recognition or something. If I can't exactly remember I can't remember the exact name. It was by one of the Google's companies, one of Alphabet's companies, uh, called I can't remember the name of the company. But if you search Google for the Kaggle challenge, Toxicity, yeah, Kaggle Toxicity challenge or something, you will see that results. So where they were trying to predict was how toxic is a given comment. Like they were trying to predict the toxicity of Wikipedia comments because it's open source. And the other thing about the data part is like data should be in the open domain because there are so many legal and regulatory problems with data. So when you are doing data collection, that's another area that you have to like be mindful about. And the other thing is something very like not recent, like it was there for a few years. Uh, the how to say it? The data should be ethical, like kind of it shouldn't be biased. With in the US, with this black movement, all this stuff. Like there are so many uh, uh, data from, let's say, for example, face recognition thing. There are so many data sets available to identify people like with white skin. But in that data set, the people with black skins are very limited. So the model is obviously biased towards the white people. So when you are doing these kind of this data collection thing, you have to like think about those stuff as well, like how to make your data set balanced, like not unbiased to certain set of people or certain set of you have to be mindful about the cultural values as well. So yeah, so about the toxicity thing, so the toxicity problem was trying to do is to predict the toxicity of that given Wikipedia comments. So if you find that challenge in Kaggle, you might be able to find the data set. So what you can do is, if you're trying to find the toxicity of speech problems, what I think is the best option is to convert that speech into text and try to predict the toxicity in that way rather than doing the toxicity analysis on the speech itself, because we, like, people have already come up with better solutions to uh, convert speech into text. So I think that would be a better way. I think just that. Helpful.
Yeah, I think that cleared out the question. I believe the answer cleared out the doubt. And let's move on to the next question. How can you handle punctuations and dialect pronunciation in text-to-speech systems? And what's the greatest limitation of production level TTS systems that can be improved on BST masters level projects? I think there are two
Yes.
parts in the
So
question.
yeah, first question, how to handle punctuations and dialects. So text to speech, right? So that's why I said don't be mixed up with text to speech and speech to text. So in text to speech, we have a certain voice, certain personality in that voice. So that's why we are considering different criteria to find this baseline voice, this reference voice. So where we think the whatever the reference voice represent most of the people, or it's from the main city or the capital city, uh, which is like even if you take single language, like there are slight differences in when people speak in maybe in Colombo and maybe in the southern parts of the country and even in the central parts of the country. People can understand, but there are slight differences with the dialects, maybe the way they speak. So we in a text-to-speech system, if you are building just one for the whole community, it's uh, hard to solve all these problems. So because of that, we will just find one system which can represent everyone. For example, when we were doing this text to speech for all these languages, what we did was we try to come up with a voice which was spoken by majority of the people. Like if you take Sinhala, like we try to find the modern or the more Kalambu like kind of the uh, speaking variations. And even in India, like if we were when we were trying to model Bengali, for example, we try to go to the Kolkata like accent or the dialect. So likewise, it depends on which what percentage that you're trying to achieve in that text to speech model. The punctuation part is handled by the text normalization that I said. Punctuations, date, times, uh, currency symbols, all these things will be taken care by the text normalization component. So for Sinhala, the text normalization is also open source. So you can search on GitHub, just try Sinhala text normalization. It's under Google I-18 and repository.
Thank you, sir. I think the sir cleared out all the doubts about the question as well. Thank you very much, sir. As we do not have much time, we cannot answer all the questions today, but we will answer them via the platform which you have submitted your question. Hope the questions asked covered some key doubts you have about machine learning. Thank you. Now that we've cleared the doubts, I would like to extend my sincere gratitude to Mr. Keshan Sodimana for taking time off your busy schedule and conducting a very interesting and informative session. I thank you on behalf of the IEEE Sri Lanka section, Techno Meetup Sri Lanka Organizing Committee, and also our participants. Thank you for joining us and staying with us throughout the session with any technical issues that arose. IEEE Techno Meetup Sri Lanka is more than just a series of webinars. We cover our multi-topic on many different fronts. We curate the Tech Innovator, a video series on technological applications, and let's spread through an open floor for all the young tech enthusiasts in the country. We also share IEEE Spectrum articles every week for you to grab knowledge on technological aspects. So don't forget to follow the IEEE Techno Meetup Sri Lanka Facebook page and to stay tuned with us so you won't miss any updates. We have now reached the end of the webinar, Human Languages from Machines Point of View. This would not have been a success if not for the participants. Thank you very much again for tuning in. We believe that you got a clear